My dear students, welcome to the world of learning physics in a really very interesting way. Please look at the video and you may share your queries in the comment box.
My dear students, welcome to the basic concepts and problems from electrostatics. And this is a continuation of the earlier lecture. In the earlier lecture, we have discussed about the Coulomb's law. Now today our first target is to discuss about the basics of the superposition principle, and then we'll do a problem that how this principle can be applied. So if we look into this concept, it is about the forces between the multiple charges. Means if there are more number of charges, more than two, then what is the effect? The principle is very clearly written, but I would like to tell you a small story. When we were very young, we had very little money with us. And when we were playing cricket, sometimes our ball was lost. So what we used to do, we used to collect 25 paisa, 50 paisa, 30 paisa, whatever little contribution from our friends, we all put it together and maybe we collected about 2 rupees or 2 rupees 50 paisa, and we used to purchase a new ball. So what was the main principle? That everybody contributed there, and the summation of the result generated a fund which was adequate to purchase the ball. So the principle here is same. We have, say, a charge. We add another charge. So if these two charges are present, they have a force acting on them, that we all know. Now we add another charge, a third charge. So if we consider the third charge, then these charges, they will be having an interaction between them. So let us understand with the help of a diagram that how this behavior is going to happen, how the charges are going to interact amongst themselves. So first, say we have a charge here. This charge is, say, Q1. And for the sake of simplicity, let us consider that this is a positive charge. We have another charge, say Q2 here. And for the simplicity of our discussion, we are keeping it. This is also Q2. And we have a distance between them as R. Or we can put a notation R12. Distance between the charges 1 and 2. Now what we do? We place another charge here. And we call this charge, say, as plus Q3. Now we want to understand what will be the implication of the presence of this charge. Very simple. This Q2, if we draw their distances, say we call this distance here as R23, and this distance here we call this distance to be R13. Now when we have this superposition principle, it is actually effect of individual forces acting. So if we have Q2, so a force, a repulsive force will act in this direction. Say we call these as F2. And because of this Q1 and the presence of this Q2, another force will act in this direction. So let us call these as F1. So if only Q2 was present, the force F2 would be active. If only Q1 were present, the force F1 would be active. Now both the forces are acting on this Q3. So now these two forces are acting simultaneously. So we can add the principle of vectors, because we know the forces are vectors. We can add the vectors and we can get the resultant force as F. Of course, these are vector quantities which should put the appropriate sign. So the resultant force is F. The resultant force is coming out to be F. So this F vector is the resultant force, which is obtained by superposition of F1 and F2. So this is very simple. Now, when the problems are given, sometimes it is given, let's say you have a square. A regular geometry is given so that it's easier to work out, because here you have to find out the angles and this and that, it becomes complicated. So we can put, say, a charge plus q1 here. We can do it with minus charges also, not a problem. So we have another charge q2 here, and we put the charge q3 here. Now we want to find out the effect. Very simple. Q1, it is acting across a diagonal, so this force F1 will be in this direction, and Q2 it will be in this direction. So the force F2 will be in this direction, and we can of course find out what will be the resultant. It will be in some direction in between. Okay, this will be the direction of the F given by the vector sum. Now if the sides A are given, okay, so q2, this is a distance a, and here this distance we can find out root over a square plus root over a square. So this distance will simply be a root 2. The distance here will be a root 2. So we can know the distances, we can apply Coulomb's law here. I just take this opportunity to remind you that it is some constant k into q1 q2 by the distance r square. So r in one case it is a, in one case it is a root 2. So we can find out f1 and f2, we can find out the angle between them, and we can of course then work out what is the direction of the resultant force. So in this way we can progress and we can find out the effect of the multiple charges on a given single charge. So this is the basic principle of superposition. Now let us discuss this problem. The problem says that there are two positive point charges. They are located on the x-axis. So at x equal to 0, the charge plus q is present, and at x equal to L, the charge plus 4q is present. This is a very simple application of the superposition principle. So we draw the figure. So this is x is equal to 0. At this x equal to 0, we have the charge plus q present, and at a certain distance given by x is equal to L, we have the charge plus 4q to be present. So obviously the distance between them is L. Now it is said that if a third charge is located somewhere in between them, so that the net force acting on this charge is 0, then determine the magnitude and location of this charge. I'd like to tell you in this regard that, say, whatever we do in such cases, the governing principle is the Coulomb's law. F is k into q1 q2 by r square. Those who have got a confusion, they can refer my earlier videos where we have discussed in depth about this Coulomb's law. And here the value of k is 1 by 4 pi epsilon naught. We prefer to write k because every time we are writing, so it saves a little bit of the effort. So here we are just showing a little bit portion. Say imagine that we place a charge somewhere in between. Now what is the location of the charge? Even before doing the problem, we can estimate, we can nurture our thoughts and understand. Imagine a story that you have got two friends who are very angry. One of them is much more angry, another is less angry. So if you want to pacify them, what do? First go to the close to that person who is less angry. Try to convince her that you don't get so much of angry. I am trying to manage that person. And that who is much more angry, we try to pacify him from a distance. So here the situation is also similar. Here the magnitude of this charge is more 4q. So we need to place the third charge away from it. It's again evident from Coulomb's law. You see here r square inversely as r square. So magnitude of charge is more means if you want to have the same force, it has to be kept at a larger distance. So we consider that this is a charge which is q dash, and according to this, so if we have a force acting here is F1, another force acting here is F2, then F1 will be equal to F2. And we can of course write F1 and F2 from this Coulomb's law. So we consider this distance as x, this particular distance as x. So this particular next portion, this distance will be L minus x. So if we write down the equation, so here for the force F1, it will be K into Q dash by x square, K into Q dash by x square, and for the other one it will be K into 4Q into Q dash divided by L minus x whole square. So we equate here the K, Q dash all will get cancelled, and if we simplify from here we will get the value of x equal to L by 3. So the claim that we made initially that this charge Q dash will be placed closer to the charge Q. So this is a very important consideration. This is about the location of the charge. This is about the location of the charge. We can evaluate. Now, to find out the magnitude of the charge, okay, so we try to find out that what is the force on the charge at of this charge q at x equal to 0. So we now try to find out the magnitude. So this is about, as we say, this is about we try to find out the location of the charge. And now we are trying to find out the magnitude of the charge. Okay, we have to find out the magnitude of the charge. And for that, we try to find out what is the force at x is equal to 0. Okay, what is the force at x equal to 0? Okay, for all the charges. And the net thing, because the system is in equilibrium, so the effective part is 0. So the force F on the charge Q, okay, so this force will be K, we can take the common, K as common, so it will be within bracket Q into Q dash, Q into Q dash divided by L by 3 whole square. In place of x we write L by 3 whole square, and then minus Q into 4Q divided by L square, and this net force will also be 0 because overall it will be in equilibrium. Overall it will be in equilibrium. Okay, so this equation, if we solve and if we evaluate, we will find the value of q dash. We'll find the value of q dash coming out to be minus 4 by 9 into q. So q dash coming out to be minus 4 by 9 into q. And using this condition, we can also subsequently find out that the charge 4q will also be in equilibrium. So in this way, we can work out, just using Coulomb's law and using the basic conditions, we can find out that how a charge can be placed at some location along with its magnitude so that the equilibrium is maintained when the net force is 0. So we'll discuss some more problems from the principle of superposition in our next discussions, and subsequently we will pass on to the concept of electric field. Till then, have a great time. Thank you.
I do hope that you've liked the videos. Please like, share, comment, and don't forget to subscribe. And also hit the bell icon so that you get the notification whenever there is a new video. So, next time we are meeting with some new concepts. Till then, goodbye.